Alright, so I'm going to take you through some of the initial steps for setting up your Raspberry Pi, like this, the infrared sensor, and your ultrasound sensor right there. So the first thing you want to do is you want to get either Raspberry Pi imager like this, or you want to get Balena Escher. Both will work, but Raspberry Pi imager comes with a few operating systems pre-installed. So you can see some of these. The one that I chose was the original one here, the 32-bit. You can kind of see it over here. This is the UI that it gives, the background. That's all the basic stuff. So once you have that installed, you're going to want to start your code. And I'll show you the code in a second here, but before you do that, you're going to want to get your API to send your data up to the cloud. So first you got to make an account with MathWorks. If you don't have that already, you can create one here. I use ThingSpeak. Yeah, so you sign up, you put in your password, sign in. So you create a new channel, call it whatever you like. You can describe it however you like as well. This is where the data comes in, so it's going to model whatever this is in a sort of histogram or chart-like fashion. You can choose as many as you like. You can get rid of as many as you like, as long as this is registered in the field right here. You can see that there. You can actually see the code here. It's my main. I'll go back to that in a second. So again, you can type in your metadata, get some tags, elevation. As you can enable your latitude, longitude if you have that going in. And then you hit save changes and it creates that channel. So I already have a channel created, so I'm going to go leave this page. Click on eBarchard thing. This is the data that's already come through. You can see that both of my data sets work. So the field 1, and field 2. You can see how it's kind of spiked up really high over here for the ultrasound. That's what happens when you put the ultrasound up against a hard surface, against its surface. And over here, I really don't quite know how this works. It's digital, so it shouldn't be going beyond 2, which is what it is right there. And it's spiked at the end here. So again, I'm not quite sure how this works. I'm new at this, so I'm still figuring it out. But this is the infrared over here, and this is the ultrasound. So the ultrasound is obviously working a bit more intuitively than the infrared is. And again, I'm not quite sure why. So going over to the circuit now, I guess. I'll show you how all this is set up. So I made a little fan here because I keep getting a low voltage signal up in the top. Oh, just turned off. Up in the right hand corner here, it says low voltage. But it hasn't, and it did originally die for a few seconds, but came back on. And well, I touched the processor. The processor was hot enough to boil an egg on, so I hooked up my fan and I put it on top. So the fan's hookup is pretty easy. You just literally hook it up to your 5 voltage power and your ground. So I have all of that kind of set up so that I have my 5-foot voltage and my ground hooking into my breadboard over here. So you can see that the voltage, positive is 5 volts, and then in the back of it, you can see the ground hooking into the negative terminal. So you can also see the fan. Fan is right here. This is its 5 volts. It's coming around and it's connecting into that positive terminal there. On the other side of things, you can see the ground coming from the fan and hooking into that negative terminal. So similarly, we have to have a positive and negative terminal for both our ultrasound. So that's what we got right here. And there's the power for that right there. And for the infrared, so for the infrared sensor, we have this thing here. Yeah, we got the power going into it, and then we have the negative going into it as well. It's interesting because you don't need it very loudly tells you that it's on with that green LED, and it actually shows that it works if you set it correctly with its potentiometers. So the way that I have it set right here is it's very sensitive. See if I can get that to focus. So it's very, very sensitive, and it needs to be kept precisely at these values, or else the only way that it seems to work and light up is if you bump it. I'll show you here. So it's showing there. So I'm going to turn this. It turns off immediately. So the only way that I get actual value from this is if I whack it, which is not what you want. Just kind of shows the sensitivity of the potentiometer. But if I adjust this up a little bit, okay, I'm gonna have to readjust it again. That's too much. And there it is. So you can see that it's very, oh crap. So you can see that it's very sensitive. So I didn't, okay. So it's kind of blinking at me right there. So again, like, I adjust this down a little bit more. Really doesn't like it. Yeah, it doesn't like it because there's stuff around it there too. So you can see, yeah. So you can see that it only works on a contact kind of thing. So you have to adjust this. See, it's very sensitive. So there it is again. So again, it's very sensitive with those two potentiometers. And yeah, so that's basically how this thing works. So out of it, we have if I get that to focus. There you go. So you can see the out pin there being pulled out, and then it comes over here, attaches to the blue, and the blue wire is attached to the 8 pin over here. The 8 pin over here, and that's supposed to be bringing in the signal of this infrared signal distance. So the idea was kind of to compare two distance related sensors. So on the other side of things, I have pins 38 and 40, the two PCM pins on the Raspberry Pi coming out of there, and they both attach to echo and trigger of the ultrasound. You can see it there. Yeah, there you go. You can see it. And then you have the VCC running into the positive terminal and ground running into the negative terminal of the HCSR04. So that's basically the rundown of the Raspberry Pi. Other than that, you have your your basic power input here. You have the power indicator light over here. Every once in a while, this will flash green. That's to show you that the processor is still in fact working, other than the obvious. Okay, and then we have the HDMI plug-in here, and that's how I have my monitor screen here plugged into it. And then I have my Bluetooth or my wireless keyboard mouse combo guy right here that I've been using. It's pretty handy. Would recommend getting one with a better mouse though. All right, so let's try and get into the code here. Just gotta wake this thing up. That's one of the nice things about this is it goes to sleep, and then you just press a button to wake it up. So the battery life tends to last forever, and it's pretty lightweight. It's a nice little guy. Anyways, yeah. So it's woken up. Sorry, and so here I guess I can show from the beginning here. So you go here and then go here. So you can see that minimized it to, come on. That minimized it to the dashboard there. So Thani is my Raspberry Pi Python interpreter. And then I have the terminal. Typically you just click the terminal here, but there are other ways you can access it. I actually find it easier because of my mouse situation. I prefer to use this. So you can look around here, you got all your stuff, but there's your terminal right there. So I can access it there if I want to. I can also go right here as well and just open it manually. I also have my Python file saved to my desktop here for easy access, so I can also just access it there. So looking at the terminal here. So what we got here is sudo python ebarchardthing.py, and then there's a bunch of string text after that. Then it's starting and 44, 0, and exiting. So what this is the full operation of that Python program that we see right there. So sudo is kind of like the admin running command for Linux. So what we're doing here is we're running Python program Python ebarchardthing.py. And then it's taking that next piece as well, which is the API, which I suppose I should show you how to generate here. So how do you get to your API? You go back to your ThingSpeak, you look at your channels, you see API keys over here, and there's your API key right there, and you'll see that matches up with the one that I have over here. So that's literally the unique identifier that I can use to attach all of the stuff that I'm trying to call to it, and I get to put it over here. And you can see that there's also a read API as well as a write API. So the write API means that you can write data to the site, to the API, and the read one means that you can read it from the site. So if I wanted to access it elsewhere, I could do that. So now I'm going to open up the code itself, and hopefully I can explain it to you here. So take it from the top. We have import time, and we're importing RPi GPIO as GPIO. So the second part of GPIO here, it's not really easy to see. Okay, so this thing here doesn't have to be GPIO. It can also be IO. It can be any other string you can think of. And it's importing sys, so there's sys functions coming in here as well. We'll see those later in the main. And URL library too. So that's what we use to push information out to the to the API. So Python doesn't have a map function like I'm used to it having in Arduino. So I made my own map function in that first little bit there. What it does is it takes a value, takes the range of that value starting off. That's what that in min, in max is. And then it outputs it to a new range of values. That's what the out min and out max is there. So let's take it down a little bit here. So we have another one. Yeah. So like with Python, you define functions with the def identifier, and that's why we see a bunch of def stuff here. So all of this stuff is being defined, and you can see at the bottom it's returning stuff. So with the get infrared data, this is the one that we use to get information data from the infrared sensor, and it takes it into the Raspberry Pi, and it holds on to it. That's what the get one does. It takes that information. So you can see the declared pin out 8 there, and set warnings false. From what I understand, makes it so that any pin, any other functions that were running on the Raspberry Pi on pin 8, in this case, on the pins that you indicate within this function, they set up warnings that will stop the operation of this program. So you have to ignore those if you want the program to continue. So that's why you set warnings to false for that GPIO, because I guess they run other functions off of the GPIO. So you can see the setup there. I'm setting up the out pin as an input so that I can read information from that sensor. It's output. It's going out of the sensor and into the Raspberry Pi. Then I'm setting. And another thing, interestingly, is you don't have to preset your variables as like ints or doubles or strings or whatever. You can just call them whatever, like out. I didn't have to declare that. It just works as is. Same way with val, and same way with analog. So val is just taking the input, unfiltered data from the sensor and putting it to val, and then analog is converting val from an analog to what I thought would work best in the chart. Again, I'm not really sure how that works. So yeah, I don't really know how that works best. It might actually work better if I just got rid of that. But I'll do that afterwards. I'll keep going with this. Okay. So the next one is get ultrasound. So this one again, you set. Another thing is GPIO set mode, GPIO board. So there's board and there's BCM. So BCM is the one where you recognize the board as it's kind of talked about in the documentation. And I don't really understand why you would do this in two separate ways. But the board is what it physically is on the Raspberry Pi. So it labels the difference in values is with BCM, you get values in the GPIO from like 1 to 14, I think, or something like that, 1 to 20 maybe. And with the board, you get access to all of them. And in that you can set pins 1 through 40. 1 through 40, because there are 40 GPIO pins for the Raspberry Pi. Okay, so we see our trig and echo being set there. Also, afterwards, you see the set warnings again. We're seeing the setup of the GPIO going in and the trig. Yeah, you see echo coming in and trig going out. And then you see the output of yeah. So then it's taking again. This is adapted from other code. So the true false thing here is it. I think what it does is it shoots out a ping. Is what the trigger is. The trigger triggers a ping for 0.00001 seconds, and then it stops. Is what the false does, and then what the while does is it takes in the echo and recognizes that in the input. So it pings back that signal that it shot off with the trigger, and it recognizes it again, um, and calculates the distance based on the start time and end time of the information received. So when the yeah, so it started when the echo is 0. So when there is no echo, it starts and it goes and it goes and it goes, and then when the echo is received, it sets to 1, and then it stops. So at that time is when the end is recognized, and then you can see in the distance calculation that the times are multiplied and then divided to get the distance value, which is then returned. So continuing down. So now we're going to look at the main. So the main. Okay, so this is the main function, the one that actually runs. You can see at the bottom there that it kind of does some of the similar kind of functioning that we see in C, where you have to call the function to make sure that it's running. Yeah, and that's basically the thing at the bottom right there is what makes this whole program actually run itself. Okay, so the main, what we have happening here before that print statement is the it's looking at the length of the argument, which is this program itself, and it's saying that if the sys argument is less than this this amount, then it's going to print out usage python t-test.py private key and then exit. So it'll kind of give an error of sorts to show that it's not working, and it'll let me know in the console by giving me that usage output there. So the next thing that it does is it prints starting. So that's why we see starting right there in the console. And then we have the base URL being defined. You can see the sys.arg v1. So what that means is sys.arg v0 would be the program itself. So you can see that recognized as the Python ebarchard thing.py in the console there. That is sysarg v0. So sysarg v1 is going to be the API that I have typed in after it there on the side. So yeah. So anyways, so then we start a while loop here. So it's going to try to get that ultrasound data, get that infrared data. It assigns it to those two variables, ultrasound and infrared, and then it assigns another two variables having to do with field 1 and field 2 of our API. You can see how field 1 coincides with ultrasound, and field 2 coincides with the infrared. So it then prints. That's what that 44 is over there. It prints the fred, which is how many times fred has been read, and then it does the same for G-Red, and then it closes both of them. And then it sleeps for 15 seconds, and then it stops, and it breaks. So that break determines the end of the program. So let's see it work. Oh, what's going on? Okay, don't actually need to have that open. So I'm just going to press up and enter. That will rerun that. I'm going to go over to the channels API. So private view. And all right, so again. So there it goes through again, exiting. Now, if I refresh this page, okay, so it's hard to see, but you can see that it's doubled up right there. Let's see if I can get another one in there. So yeah, you can see the cluster getting bigger there. It's just kind of hard to see. I'm gonna adjust this at all. No, okay. Yeah, I might be able to. Well, here I can just adjust this to. Okay. Try to get this to a stable position. Okay, great. Now there's a diode sticking out of it. All right, let's try to see that work. Try one more time. Okay, so you can see it kind of dive there. Here I can actually